Welcome to this video. Today, we'll dive deep into how Formula 1 engines and gearboxes work. We'll go through the main components, their performance and function, how many power units are allowed per season, how the energy recovery system, the ERS, works both technically and in practice, and finally, how the engine regulations will change from 2026 onwards. Section 1: The modern Formula 1 engine. Since 2014, Formula 1 has been using hybrid power units. That means an F1 engine is not just a combustion engine, but a highly complex system made up of several parts. At the core is the 1.6-liter V6 turbocharged engine. It has 6 cylinders in a 90-degree V shape, weighs around 150 kilograms, and revs up to 15,000 RPM. On its own, the internal combustion engine produces roughly 700 to 750 horsepower. Attached to it is a turbocharger, which compresses the air going into the engine for higher efficiency and power. This turbo is also linked to one of the hybrid systems, the MGU-H, which we'll cover in a moment. Section 2: The hybrid components. The modern Formula 1 power unit consists not only of the V6, but also of two major hybrid systems. MGU-K, short for Motor Generator Unit, Kinetic. This system recovers energy under braking. It works like a generator when the driver slows down, converting kinetic energy into electrical energy. During acceleration, it switches roles and acts as an electric motor, sending extra power to the rear wheels. It can provide up to 163 horsepower instantly. MGU-H, H stands for heat. This unit is connected to the turbocharger. It harvests energy from the hot exhaust gases to generate electricity. It can also spin the turbo electrically to eliminate turbo lag, giving drivers smoother and more immediate throttle response. Together, these systems make the car far more efficient. The complete power unit, combustion plus hybrid, produces around 1,000 horsepower in total. Section 3: The battery and control electronics. The recovered energy from the MGU-K and MGU-H is stored in the energy store, basically a high-tech lithium-ion battery. Managing all of this is the control electronics, which decide when to harvest, when to deploy energy, and how to balance performance and reliability. Drivers can deploy electric energy manually in certain modes, for example during overtaking, or the system can do it automatically to maximize efficiency during a race. Section 4: Gearbox technology. Power is nothing without control, and that's where the gearbox comes in. Formula 1 gearboxes are 8-speed sequential gearboxes plus reverse. They're incredibly lightweight, built from carbon fiber composites and titanium, and use seamless shift technology. That means drivers can change gear without any interruption in power. Gear changes are so quick, they happen in just a few milliseconds. Gearboxes are mounted at the rear of the car, not only to transfer power but also as a structural component of the chassis. The rear suspension and other parts of the car are directly attached to it. Section 5: Reliability and season limits. To control costs and improve reliability, the FIA sets strict limits on how many engine and gearbox components each driver may use during a season. Currently, the limits are: for internal combustion engines, for turbochargers, for MGU-K units, for MGU-H units, 2 energy stores, 2 control electronics, 8 exhaust systems, and 4 gearboxes. If a driver goes beyond these limits, they receive grid penalties, meaning they have to start further back in the race. This forces teams to carefully balance outright performance with long-term durability across the whole season. Section 6: How ERS works in practice. So, how does ERS actually work during a race? When the driver brakes into a corner, the MGU-K recovers kinetic energy and sends it to the battery. At the same time, the MGU-H harvests energy from the exhaust gases. When exiting the corner and accelerating onto a straight, the stored energy is released. The driver gets an extra boost of electric power, about 160 horsepower, on top of the combustion engine. This not only helps with overtaking, but also reduces fuel consumption over the race distance. ERS is so advanced that it accounts for about 20% of the car's total power output. Section 7: The big changes coming in 2026. Now, let's look at the future. From 2026, Formula One will introduce a brand new engine formula. The 1.6-liter V6 turbo will remain, but the balance between combustion and electric power will change dramatically. The MGU-H will be completely removed. This simplifies the power unit and reduces costs, making it easier for new manufacturers to enter the sport. The MGU-K will become much more powerful. Its output will increase from today's 163 horsepower to around 470 horsepower. That's almost 3 times as much electric power as today. The overall power will remain close to 1,000 horsepower, but nearly half of it will now come from electric energy. In addition, the fuel will be 100% sustainable, made entirely from renewable or synthetic sources. These changes aim to make Formula One more environmentally friendly, more road relevant, and attractive for manufacturers like Audi, who will join the sport in 2026. Section 8, Conclusion. To sum it up, modern Formula One engines are masterpieces of engineering, combining a small but incredibly powerful V6 turbo engine with advanced hybrid technology. Together with lightning-fast gearboxes, they deliver nearly 1,000 horsepower while still being surprisingly fuel efficient. The strict rules on components add a big strategic challenge, and the upcoming 2026 regulations will push Formula One into a new era of electrification and sustainability. That's it for today's deep dive into Formula One engines and gearboxes. If you enjoyed this video, make sure to like, subscribe, and let me know in the comments what topic you'd like to see explained next. Thanks for watching, and see you in the next one.